Okay, so we're continuing to use relationships that we know from our place value chart to multiply and divide numbers without using the chart itself. We just have to remember some of those tricks. Well, one of those tricks is paying attention to the number of zeros in our problem. Now here, we're dividing by 10. So if we divide by 10, that means that we can make our number smaller. And if we make our number smaller, we're only going to move it one place value because that's how many zeros are in our problem. So I'm going to move it smaller, one place value, getting 15 and 2 tenths. Here I'm going to move it smaller, two place values, because I'm dividing by 100, and I'd get 1 and 52 hundredths. Here I'm going to divide by 1,000, moving my place value 1, 2, 3 and making it smaller, getting 152 thousandths. Explain why you decided where to place the decimal in the quotients for A, B, and C. The decimal point was moved based on the amount of zeros in the problem. When we divide by a number like 10, our value gets smaller, which means that we move that decimal point so the number would be smaller. Here I'm multiplying by 10. Okay, I'm multiplying by 10. And that means my answer, or my product, is going to be bigger. Here, I divided by 10, which is the same as multiplying by 1/10. Multiplying by 100th or multiplying by 1,000th, depending on what number you were dividing by. Here, we're multiplying by 10. So I'm going to write my original value, and I'm going to move that place value once to make it bigger, once to make it bigger, and my invisible decimal point would be here. Again, count from the decimal point, 1, 2, 3, place your comma. Here I'm multiplying by 100, 2 zeros in my product, or in my problem. So I multiply, and I move one place value, two place values, place my invisible zero, or I'm sorry, my invisible decimal point, 1, 2, 3, put a comma, 1, 2, 3, put a comma. I'm multiplying by 1,000, so I'm multiplying by 10 3 times, 19340, so that means I'm going to move it one place value, two place values, three place values to make it bigger. Explain how you decided on the number of zeros in the products for A, B, and C. The number of zeros changed when we multiplied by a power of 10. Each zero in my problem moved my decimal point once and made the product bigger. Made the product bigger. Let's look at number 3. Janice thinks that 20 hundredths is equivalent to 2 thousandths because 20 hundredths is equal to 2 thousandths. Well, if that's true, let's go ahead and look at that. We're going to use a place value chart to help us prove that they're wrong. So we're starting with thousands, Notice that's not a snake number, no THS at the end. Thousands, hundreds, tens, ones, tenths. Those are snake numbers. Hundredths and thousands. Okay, so if I know 20 hundredths, 20 hundreds, notice how it's ending in the hundreds place, is equal to 2,000s. Does that then mean that 20 hundredths, so here's my hundredths, is equal to 2,000ths? Well, that 2 would be over here. That's not even the same thing. 20 hundredths would be equal to 2 tenths, but not 2 thousandths. Use words in a place value chart. 20 hundredths is equal to 2 tenths and not 2 thousandths. Canada has a population that is about 1/10 as large as the United States. If Canada's population is about 32 million, about how many people live in the United States? Explain the number of zeros in your answer. So 32 million. 32 million. So that's 32,000, 3,200,000, 32. Oops, I lied. 1, 2, 3. 1, 2, 3. 32 million in Canada. How many people live in the United States? So if this is 1/10 as much, then that means the United States would be there. Because here I divided, if I take this number and divide it by 10, I'd get this number. If I take this number and multiply it by 10, I'd get this. So this is the US's number. Explain the number of zeros in your answer. I placed another 0 in my answer so that it would be 10 times as large as Canada's population. That's it for our problem set.